All right, and we're back. All right, I have another quadratic equation. I do have it set to 0 already, so that's one step out of the way. First step is always to try to pull out a greatest common factor. Unfortunately, I don't have one between x and 25, so I need to move on to the next thing. See that there are two terms? Because of that, the other method that we learned back in Unit 4 was that if we have the difference of two perfect squares, and in this case we do, I can factor that relatively easily. It's automatically going to set up into two sets of parentheses, still going to be equal to 0. Since I have the difference of two squares, to factor it, one will be plus, one will be minus, and then I'll have the same pieces in each. That means since this x squared is a perfect square, I just take the square root of it. I get x from both. I see that 25 is a perfect square. If I take the square root of it, I get a 5 and a 5. Now, after just recognizing the difference of two squares, factoring that difference of two squares, I see that I now can apply the zero product property. How did I know that? Because I have something times something equal to 0. Once I have that, I know that I can set them both equal to 0. All right. So just like in the last video that we did, I have x plus 5, and actually I don't need that set of parentheses. Set that equal to 0. Let me get rid of that. And then I also have x minus 5 equal to 0. I'm trying to solve this thing for x, so let me get rid of this 5. There's a positive 5 there, so let me subtract 5 from both sides. When I get rid of that, I'll find that x is equal to negative 5. Now on this one, I have a similar setup, except I already have a minus 5. Let me go ahead and add 5 to both sides. If I do that, then x will equal positive 5. So my two solutions for solving this difference of two squares right here are negative 5 and 5. I'm going to do another one of these with maybe one extra step, but I'm going to stop here for this one. All right, talk with you later.